In 1975, they began in Karlupy nad Vltavou the operation of a refinery for the production of automotive fuels. In those times, fuel oil products were in great demand. The requirement of quality fuels due to the negative impacts of emissions during the 80s and 90s have changed. For this reason, the shareholders of the Česká rafinérská decided to build into their refinery a conversion facility, which would make it possible to change the long distillation residue, the heavy fuel oil, to modern, higher value white oil products. In April 2001, the operation of the new vacuum distillation and fluid catalytic crack complex has been started from a new central control room. This moment crowned the 3-year effort of a few hundred technicians, designers, and builders, literally from all over the world. But let us go back to the year 1999. The civil works started in June by the building of the foundations for the future processing equipment, which will rise up to the height of 120 meters above the adjacent terrain. The whole plant will be lying in the reinforced concrete foundations, sloped toward the drainage channels, which are lined up with the water treatment system. The very first above-ground civil works belong to the construction of a 120-meter reinforced stack. With international expertise, the production of special pieces of equipment began at different domestic machinery companies. 2 of the high-tech vessels used for the fluid catalyst cracking process were fabricated in Belgium by a supplier familiar with this type of construction. Transport through the North Sea to Hamburg and then on to Mielnik's port, utilizing the Labes water route and then local roads. The transport of the FCCU regenerator with the length of about 15 meters and of diameter of more than 5 meters required considerable effort of specialized transportation firms. High expertise of assembly companies came in use during erection of the approximate 38-meter high column. At the height of 29 meters, the generator in the fluid cracking unit was lifted and installed. Alloy-clad stainless steel material and entrails of over 3 meters in diameter represented a respectable load, weighing several tons. The first loading of the reactor and regenerator consumed 2,000 tons of the catalyst. Regenerators of catalyst of the diameter of up to 8 meters and the whole height of approximately 31 meters were outfitted by a few hundred square meters of internal erosion-resistant insulation lining. The highest installed equipment represented over 44 meters high main columns of fluid cracking with diameter over 5 meters. The construction of vacuum distillation and fluid cracking units were ensured by the substantial number of foreign firms used. The manpower on site peaked at over 1,500 workers during the summer of 2000. The power station of Caoutchouc, the refinery, and the catalytic crack will swap steam and condensants for further use. The project preparation as well as the whole construction project was managed by Dan Nicodemus.
I believe what was special about this project was the fact that we've exceeded the 4 primary project objectives that were established at the beginning of the project. in the areas of safety, quality, schedule, and cost. Our number one priority on the project was safety. In the area of quality, I believe that the assets that we'll hand over to CRC are very reliable and will be proven in the years to come. In the area of schedule, we've completed the project and we've been up making products within 29 months from the time that the shareholders approved the project back in November 1998. And finally, the final cost of the project will be significantly under the original budget. The fact that we've achieved and exceeded these critical project objectives makes this project special. Our primary contractor, Flair Daniels and ABB Lummis, both played critical roles in the success of the project. A very pleasant surprise was the high level of craftsmanship demonstrated by the construction workforce. The quality of the asset and the finishing ahead of schedule can be directly attributed to the excellent labor that was available for the project. And finally, the primary reason for our success was our project team. This was special to me not only because of the hard work and dedication by many of the individual team members, but because it was a multinational, multicultural team consisting of experts from our shareholders that was blended with the local knowledge of the permanent CRC staff and supported by the resident subcontractors.
Mr. Bill Weisenborn was responsible for the technological supervision.
When we built the new units, we had to tie it into existing units. We reallocated tanks in the tank farm to increase our storage, and this allowed us to handle those products, and those tie-ins were scheduled with the movement of products. We also did work in existing units like the sulfur plant.
The training of the operators and the startup of the new process facility was managed by Mr. Adolfo Mrevlak.
Here are we in the control room of the cat cracker and the vacuum unit. Here all the new units are being controlled automatically. Normally here now we sit with 2 or 3 panelmen, and that's because we are already at normal operation. The critical moment was when we started up the cat cracker. In that moment we start to send the feed to the riser, and we start to produce suddenly a lot of light hydrocarbons. During that moment we had to operate here up to with 5 panelmen. Why? Because a lot of changes happen, pressures are increased, temperatures increase, and a lot of gas, LPG and naphtha are produced. Also, because of this, only one panelman was only looking into the environmental problems, ensuring that there was no contamination going on, ensuring that we were not flaring too many gases. That is a critical moment. That was the most important moment, and fortunately with this panel and with all the operators we succeeded to do it properly.